Now, you can always use Desmos to check while you're practicing. All right. But I want you to at least be able to try to do it by hand first. So, like on your homework from last night, if you did use Desmos to check yourself, that's totally fine. All right. Okay. So, the first one right here on that yellow sheet. So, I told you guys you didn't have to find the x or y intercepts, all right, because we didn't really discuss that. And to be honest, for this class, you don't need to worry about that. That's more of a math 3 thing, all right? All I cared about was if you could find the vertical horizontal asymptotes and if you could graph it. So find corner points. So first off, vertical asymptote. How do I find it? Right, we set this denominator equal to 0, solve for x. So x plus 1 is equal to 0, so x is equal to negative 1. So vertical. So think about it this way. Vertical asymptote, it's a vertical line, and if you look, vertical lines typically involve x values. All right, like if you look at the grid, if you look at an x value, they have a vertical line next to it. Horizontal, if you look at the y values, they have horizontal lines next to it. That's the way you can remember it. So my vertical asymptote is x is equal to negative 1. So I'm going to go ahead and plot that. Remember, to represent an asymptote, we just draw a dotted line. All right. How do I find my horizontal? It's not C, it's the K value. All right. What's my K value? Negative 2. So my horizontal asymptote is at y is equal to negative 2. And remember, that's if you were given the general form, which is a over x minus h plus k. All right, that's the general form of a rational function. All right, guys, if you could please put your Chromebooks up for me. You don't need them. So I'm going to go ahead and plot that one as well. Now, your asymptotes are like your fences, okay? They're your barriers. So remember, your graph should not at any point cross those two lines. Now, there's two ways that you can go about doing this, okay? So there was my way that I taught you guys yesterday, and then there's the other way. So I'm going to show you a different method first, and then I'll show you how to get another point using my method, okay? So this method may be easier for some of you guys that were struggling yesterday, okay? So what you want to do is you're going to take the vertical asymptote, all right? And you're going to make pretty much a table where your vertical asymptote is kind of the middle. And remember, since this negative 1's your vertical asymptote, that means the y is undefined. All right, if you really want to kind of say it has a value, even though that you won't actually plot it, you could say it's negative 2 because that's the horizontal. All right, doesn't matter, but just know it's undefined. So typically some nice points can be found if you go one above and one below. All right, so if I go one above, that would be 0, and one below would be negative 2. And then I just have to plug them in to the original function to get corner points. So if I plug in negative 2 first, I got 6 over negative 2 plus 1 minus 2. All right. Then this will be negative 6 over negative 1 minus 2. So that'll be 6 minus 2, which is what? 4. So I have a point at negative 2, 4. So right here. For 0, I have negative 6 over 0 plus 1 minus 2. So that would be negative 6 minus 2, which is what? Negative 8. So I have a point at 0, negative 8, which is right here. So that's one way you can get your corner point. So that's kind of an easier method than, or at least it's another method that I didn't necessarily show you yesterday, but it's essentially how you can get the A value. All right. So remember how yesterday I said you want to shoot for the A value? Well, you got the A values. Now, what was the other thing I told you to shoot for yesterday? Like the fraction itself. So like when you evaluate that fraction, I told you to shoot for the A value and its opposite, and then also what? What number do I want? What nice whole number do I want that fraction to evaluate to? 1 or negative 1. All right. So now I'm going to show you my way to get the 1 or negative 1, or at least the way I showed you yesterday. So remember, first things first, we just want the fraction part by itself. We don't care about the minus 2 yet. Okay, we're going to shoot for this to equal 1 first. All right, so remember, if we want this to be equal to 1, what does the x plus 1 have to equal in the denominator? Negative 6. So what x value, if I plugged it into x plus 1, would give me negative 6? Negative 7. So negative 7 would be one of our x values. And a double check, negative 6 over negative 7 plus 1, that's equal to negative 6 over negative 6, which is 1. Now, that's the first part. And then to get the y, all we got to do is subtract 2 from 1, which is what? Negative 1. So that's our other point value. So we also have a point at negative 7, negative 1. Now let's shoot for negative 1. So we have negative 6 over x plus 1 is equal to negative 1. So what value should the x plus 1 equal to? So in other words, in the denominator, what does the denominator need to be? Right, it needs to be 6, because negative 6 divided by 6 is negative 1. So what x value, if we do x plus 1, what x value would give us 6? 5. So our x has to equal 5. To check, we'll do negative 6 over 5 plus 1, which is just negative 6 over 6, which is negative 1. And then to finish it up to find our y, we just need to subtract the 2. So that'll be what? Negative 3. So there's another point at 5, negative 3. So right here. So I don't care which method you do. If you like mine better, use that. If you like just to find one above, one below, that's fine too. All right, I don't care. So remember, your final graph, you want to start at one of the asymptotes, go through one of the corners, curve till you hit the other corner, and then it should get really close to the other asymptote. So that's the first part of the graph. The other part of the graph is you start the asymptote, hit the corner, curve, so you hit the next corner, and then get really, really close to the other asymptote. And that's the second part of the graph. Any questions on that? So again, pick a method that makes the most sense to you. If you liked what I did yesterday, use that method. If you just want to do one above, one below, whatever the vertical asymptote is, that's fine too. Now, just for funsies, what's the domain and range? All real numbers except what? -1. So for the domain, it's all real numbers except x cannot equal -1. You could have also written it as -infinity to -1 union -1 to infinity. Make sure you recognize both because on your test it kind of flip-flops all the time. What about range? Except y cannot equal -2. Or you could have also written it as -infinity to -2 union -2 to infinity. Either way. If that was an open-ended question, I would accept it either way. But if it was a multiple choice, make sure you just recognize both ways. Any questions on the first one? All right, let's do the second one. So first things first, vertical asymptote. How do I get it? Sit. X, the denominator, so x minus 6 equal to 0, which would be what? What would x equal? 6. So x would equal to 6. So it would be right here. Horizontal, what is it? It's 6 because my k value is 6. So it'd be y is equal to 6. So it'll be right here. All right, so I'm going to get 2 points on each side. So I'm going to do the new method first, and then I'm going to do my method second. All right. So I have a table, x, y. Remember, you want to set your vertical asymptote as kind of your middle. So 6, and just know that that's undefined at 6. And if you also know where the y is also undefined, you can also say it's at 6, whatever you need to do. What's 1 below 6? 5. What's 1 above 6? 7. So those would be the first two x values we get first. So I'm going to plug 5 in for x in my original. So 5 over 5 minus 6 plus 6. So this will be 5 over -1 plus 6. So what's 5 divided by -1? -5. So this will be -5 plus 6, which is just what? 1. So that's my y value. So I have a point at 5, 1. So right here. All right, now 7. So I have 5 over 7 minus 6 plus 6. So this will be 5 over 1 plus 6, which 5 over 1 is just 5, plus 6 is what? 11. Now it goes off the graph a little bit, but it's only one more, so you can just add the notch. So this will be 7, 11. So right here. Now, I'm going to use my other method to find 2 more points. And so now I want the fraction itself to be equal to 1 and -1 after I evaluate it. So I'm going to do 5 over x minus 6, and I want it to equal 1 first. So if I want that fraction to equal 1 after I evaluate it, what value should I have x minus 6 equal to? 5. So I need that equal to 5. So what x value, if I subtract 6 from it, would give me 5? 11. So that'll be one of my x values. If I double check myself, that'll be 5 over 11 minus 6, which is 5 over 5, which is 1. And then I just have to add the 6 to get my y, which is what? 7. So when x is 11, y is 7. So right here. Now I want it to equal -1. So what value would I need to put in my denominator? Or in other words, what will my denominator have to be? It needs to be -5, right, in order for it to equal -1. So what value of x, if I plug it in and subtract 6 from it, would give me -5? 1. So that's my other x value. To check myself, I have 5 over 1 minus 6, which is equal to 5 over -5, which is -1. And then to finish it up, I just need to add the 6. So what would that be? 5. And that's the y value. So my other point is at 1, 5. So now I got a pretty good idea where my graph is, so I can draw. Wait, which part are you talking about? 1, 5. No, because we want to equal to -5. So since -6 is bigger than -5, you have to technically add a positive 1 to it. So to draw our branches, we start at the asymptote, go to one corner, turn, hit the other corner, and then get really, really close to the other asymptote. There's your first part of the graph. Second part of the graph, start the asymptote, turn, go the other corner, get really, really close to the asymptote. And there's your other graph. Does that kind of clear up any confusion you had on? Yes.
Once we get like the first point, can you just like say like this one's 5 away from the graph, so the other one has to be 2, and just do that?
I mean, you could. That's the way you could think about it. Yeah. There is a little bit of symmetry to it, yes. All right, so does that kind of clear up any confusion that you guys had? All right. Okay, so before we get into reviewing, one last thing. Domain and range. What's the domain of this graph? Except x cannot equal 6. Or you could have also written it as -infinity to 6, union 6 to infinity. Either way. What's the range? Right. Same thing, except now it's y can't equal 6. So it'll literally be the exact same thing if you wrote an interval notation. All right. Okay, so the last thing that we're going to do before we get into reviewing, we need to go over the last little part of 5.7, which is just solving the equation. So we're getting away from graphing entirely. Now we're going into solving some very simple rational equations. So take out your packet and go to page, I think it's 38. Yeah, 38. All right, so you're in your packet, page 38. All right. Shh, 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 shh. Okay. So, first off, before we do anything, we first need to review something that we talked about yesterday, which is the excluded values of a rational function. All right, so that includes the asymptotes, but specifically, we want to talk about what would make the fraction undefined. So, in other words, we're not talking about y values, we're talking about x values. So, think vertical asymptote. All right. So, how do you think I would figure out where my fraction is undefined? Ashlyn. Yeah, like for A. Right. So we're going to set the denominator either equal or not equal to 0, whatever floats your boat, because we know that our denominator cannot equal 0. All right. So what can x not equal to? So it's undefined at x equals 2. What about for the next one? What do you think? X cannot equal 0. Now, the last one. Think about this carefully. What's the denominator look like to you guys? It's a what? It's a difference of squares. So what do you think I'm going to have to do first before I set it equal to 0? Factor it. How would I factor that difference of squares? X minus 1 times x plus 1. So this actually has 2 excluded values. So if we were to graph it, it would have 2 vertical asymptotes. All right. So if I want to find it, I'm going to set both of these not equal to 0. So x cannot equal what for the first one? 1, or x cannot equal what? Negative 1. So we can rewrite this as x cannot equal the set of negative 1 or 1. All right. Now, why is that important? This comes into play with equations because of extraneous solutions. So we talked about this with radical equations. What does extraneous solutions mean? They don't go back into the problem, so they don't make the problem true, or what happens? It'll make it undefined. So in terms of rational solutions, if you plug the extraneous solution back in, it should give you an undefined. So in other words, it would make the denominator 0. All right. Now, let's actually look at the steps. So there are 2 types of rational equations. You're going to learn how to solve both of them, both types in Math 3. But in Math 2, we only want to focus on the easier type, which is proportions. All right. And technically, you already know how to do this. All right. This is kind of a middle school skill. All right. You probably learned this when you guys did percents, like converting or finding how much of a number is a percent of another number, stuff like that, or how much, or like if you're given one fraction and a denominator, what's the numerator, things like that. Okay. So first thing we're going to do, cross multiply. All right, you're going to start, because you're going to have one fraction equal to another, you're going to start by cross multiplying. So some of you may know that as the butterfly method. You would then solve the resulting equation. Now, be careful, because this could either be a linear or a quadratic. So you could see both. And then you need to check for extraneous solutions. So what they would do is it would make at least one of the fractions undefined. If it makes at least one of the fractions undefined, meaning it makes the denominator equal to 0, it's an extraneous solution. And what do we do with the extraneous solution? We throw it out. All right, we throw it out of our solution set. So let's look at example 1. All right, first thing we're going to do, we're going to cross multiply. So I'm going to multiply 5 times x minus 2, and then I'm going to do 3 times x minus 4. And we're going to set them equal to each other. So I have 5 times x minus 2 equal to 3 times x minus, or x plus 4. Now we got ourselves a nice, simple linear equation. So what do I need to do first to solve? I need to distribute on both sides. So I get 5x minus 10 is equal to 3x plus 12. What do I do next? I'm going to move the 3x to the other side, and to save some time, I'm going to go ahead and add the 10 as well. That goes away, that goes away. I get 2x is equal to 22. And what's the last step? Divide by 2. So x is equal to 11. Now, even if we only get one solution, we still need to check for extraneous. So to check for an extraneous, you really just need to plug it back into the denominators only. So if you have an x in a numerator, you don't need to worry about it. You really just need to check the denominators. So 11 plus, so ask yourself, 11 plus 4, will that give me 0? No. 11 minus 2, will that give me 0? Nope. It's a solution. That's all you got to do. Any questions on example 1? All right. Let's look at example 2. A little bit different. Okay. So still doing the same things. We're going to cross multiply first. So I'm going to have x minus 3 times x minus 4, and it's equal to 2 times 1. Now, the left side of our equation, how would I evaluate that? FOIL, box method, whatever. All right. So we're going to end up with a what on the left side? A quadratic. All right. So you guys could FOIL that on your own. So I'm just going to tell you what it is. So it's x squared minus 7x plus 12 is equal to 2. So to solve a quadratic, what do we have to do first? Move the 2 to the other side. So I get one side equal to 0. So I have x squared minus 7x plus 10 is equal to 0. Now, if I give you a quadratic proportional wise, more often than not, you'll just be able to solve it by factoring. All right. So you shouldn't have to really do quadratic formula or anything. But if you like quadratic formula, you can always use that. It'll solve any quadratic. So I'm going to go ahead and factor this. Do I need to go over the factoring side of it, or are y'all decent at factoring? So factored, this would be x minus 5 times x minus 2 is equal to 0. Then what do I do? Set both equal to 0. So x minus 5 equal to 0. X minus 2 is equal to 0. So x would equal 5. X would equal 2. Then I need to plug it back in to make sure nothing's 0. Now, in the denominator. Now, there is an x in the numerator for the first fraction, and then a whole number in the denominator. We don't actually need to plug in either of our x's into this first fraction, because all I care about is if the denominators are 0. And since this already has a 2, this fraction is going to be good regardless of what we do. All right, because the numerator can be 0, because anything divided into 0 is just 0. We just can't divide something by 0. So if I plug in 5 for my second fraction, 5 minus 4, will that give me 0? 2 minus 4, would that give me 0? No. So both of those are in my solution set. And that's it. Not too bad, right? Pretty straightforward. All right. Example 3 looks like example 2, so do I need to go over that one? No. All right, so let's go over example 4. A little bit more to it, still same process. So I'm going to start by cross multiplying. So I have 1 times x squared plus x minus 2, and it's equal to 2 times x squared minus 1. So we know we're going to have a quadratic equation. So before I do anything, what do I need to do first? I just need to distribute. All right. So multiplying 1 by anything is just itself. So this would be x squared plus x minus 2. And this would be 2x squared minus 2. Now what I need to do. I would not subtract 2x squared. Why? Yeah, typically when you solve a quadratic, you want to have a positive a value. So instead of subtracting 2x squared, we're going to subtract the left side over to the right. All right, so I'm going to subtract x squared, x, and add 2. So I'm going to subtract x squared, subtract x, add 2. That goes away. I get 0 is equal to x squared minus x, and then the 2's cancel out. So if I solve by factoring, what's the only thing I got to do? I just need to factor out GCF of x. So 0 would equal x times what? X minus 1. Then I would set both of those factors equal to 0. Remember, since the GCF is a variable, we have to set that equal to 0. So x is equal to 0, x minus 1 is equal to 0. That means x has to be either equal to 0 or x is equal to 1. And I need to check both. So just do a little bit of mental math. 0 squared is 0, minus 1 is negative 1. 0 squared plus 0, so that'll be 0 plus 0, minus 2, that's negative 2, so 0 is good. Now 1. 1 squared is 1 minus 1. What does that give you? So automatically, we don't even have to check the second one. Automatically, x equals 1 is a what? It's extraneous. So it's gone. So our answer is just x equals 0. So as long as you get 0 in the denominator for one of your fractions, you don't even need to bother checking the other. All right, any questions? All right. Last one, let's do example 5. So, same process. Cross, son of a biscuit. There we go. So, same process, cross multiply first. So, I have 3 times x squared plus 5x minus 2. And it's equal to 4x plus, or 4x minus 1 times x plus 3. So I need to distribute the left side, FOIL the right side. So I distribute that, I get 3x squared plus 15x minus 6. And I know that y'all are fully capable of foiling or box methoding, so I'm just going to work it out really quickly. So this would be 4x squared plus 11x plus 12. Or minus 3, sorry. I didn't cross my T's there. All right, so still dealing with the quadratic. So what do I need to do first to solve? Which side should I be subtracting over to the other? The left. So I'm going to subtract the 3x, the 15x, and add the 6 to both sides. Or 3x squared, sorry. Whole left side goes away. I get 0 on that side is equal to x squared minus 4x plus 3. Factor it, which is an easy factor. It would be x minus 3, x minus 1. Set them both equal to 0. What's x equal to? 3 and 1. But we don't know definitively if that's the answer, so I need to check it. So we really only need to check the leftmost fraction. So 3 plus 3, will that give me 0? No. 1 plus 3, will that give me 0? Nope. So both are my answers. So x is equal to the set of 1 and 3. All right. Now, we're not going to do number 6, but if there's no fraction on the left side, what do you think you're going to have to do? Put it all over 1. Or yeah. Okay, so if you don't see a fraction on one side, just put it over 1, then cross multiply. But we're not going to work that one out. All right, any questions on anything on 38? All right, so for the rest of class, what I want you guys to do is work on your review packet. So it covers everything from 5.1 to 5.7. Remember, we're not going to do 5.8 on this test, which also means for your journal, you do not need to do the 5.8 one-pager. All right. So if you want to cross that one out, so you remember not to do it, you don't need to do it. I'm going to say next Tuesday. If you want. So, listen, I already posted the key to the review. So if you get stuck, you can look at that. But I will also take